Welcome back to my channel. For today's video, we're gonna do an edible molecule, a dodecaine specifically. And since we'll be doing an edible molecule, we need to ready our ingredients first. But before that, of course, we need to wash your hands so that our molecule will be more safe to eat. So let's go to our sink.
A few moments later.
Get ready our ingredients. We literally flew to America from Philippines just to buy ingredients that we're gonna use. And of course, we rode an airplane that has a good pilot. Just kidding. So we actually bought our ingredients in a store near us that is owned by my aunt. Taka naman tita. Just kidding. So here's our ingredients that I bought. Hope, a biscuit, bits, a candy that looks like a burger, I don't know what it is called, and of course the gummy worms. And I only bought this all in a cheap price that can be estimated as 30 pesos in all. So what are you waiting for? Buy now in my aunt's store.
What? I don't get it.
Oh, Teddy, okay, just for you, I'm gonna make it clear. Do you know what hydrocarbon is? Hydrocarbon is an organic compound which focuses only on hydrogen and carbon. Aliphatic hydrocarbons are divided into three main groups, which are the alkanes, alkenes, and alkynes. Alkanes have only single bond. Alkanes contain a carbon-carbon double bond, and alkynes contain a carbon-carbon triple bond. What we're gonna do now is a dodecaine.
Dodecaine?
Dodecaine, for those who don't know, is a liquid hydrocarbon straight-chain alkane, which means having only single bonds with 12 carbon atoms. As can be seen in your screen, basically the alkane formula is CnH2n plus 2. And how does it become our guide in getting the molecular formula? Well, I'm gonna show you then. Since I said a while ago that a dodecaine consists of 12 carbons, then we will change the n into 12, which will make it as C12H2 multiplied to 12 plus 2. And multiply the 2 to 12 and it will be C12H24 plus 2. And when we simplify it, we will get an answer of C12H26. C12H26 is the molecular formula of dodecaine. And what is its structural formula? I don't really recommend you to use a towel, but since there are 12 carbons and it is not well fitted on the plate, I have no other choice but to use it so that you can clearly see this all. So what do we have here? We have the hope as the hydrogen, the burger as the carbon, the gummy worms, and of course the bits that will serve as the band or line that connects the hydrogen and carbon. As you will notice, I put it in a container so that our ingredients would be arranged properly. And since we have 12 carbons, we'll be making that first. Then, tada! That's it! And these bits connect the carbon to each other. Next step is getting the gummy worms so that we can put that here and we'll make as the line. Here is our result. And of course the hope as the hydrogen. Yay! So this is our structural formula. Let's count it first so that we can make sure that we done it right. So the carbon is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Did we get it right? Yes! Now next is the hydrogen. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, and of course the 26. So we got a total of 26 in hydrogen. So we come up with the answer of C12H26, which is the molecular formula of the dodecaine. So we got it right. Let's go now in making the skeletal formula of dodecaine. Skeletal formula is basically the most basic one for me. Why? Because it is only composed of lines with nothing but just a line. It's like a skeleton, alright? And I'm gonna teach you and show you how to read and do a skeletal structure. Let's go! Since it is only a skeleton, we'll let the gummy worms alone and make the dodecaine itself. Just kidding. So what do we have here? These are the gummy worms that I actually caught. But then in making a skeletal formula, we have to attach it to itself. And just like that. Which will look like this. So we have to put it like that. And yeah, attach it to itself. Like that. Just like that. So this will look like this as a result. Isn't this so beautiful? OMG, I'm so good. Just kidding. So in making a skeleton formula, make sure that you count from the starting line until the end. You're basically counting at the bottom and top part of the mountain. So let's count now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Actually, here you gotta count the carbon only. And we got it right. We have the 12 carbons. So, yes! We are in the last formula that we'll be making, and that is the condensed formula. The condensed formula of a molecule is the formula where the symbols of atoms are listed in order as they appear in the molecule structure with band dashes omitted or limited. And we can actually determine that through the use of our molecular structure formula that we done a while ago. So this is the structural formula, and we only have to count the hydrogen that is attached in the carbon. And since the first one have 3, which will make it as CH3. So put it there. And as you can notice, there are 10 carbons that have 2 hydrogens attached to it, and a CH3 in the last part. In conclusion, it can be written as CH3, open parenthesis, CH2, close parenthesis, 10, CH3. The reason why we have parentheses and 10 on the side is for us to easily know that there are 10 CH2 in the dodecaine. In summary, the dodecaine have 12 carbons with molecular formula of C12H26, wherein condensed as CH3, CH2, 10, CH3, and the skeletal formula drew like this.
Where do we use the dodecaine?
Well, dodecaine is a component of gasoline and is used as solvent in organic synthesis, in jet fuel research, as a distillation chaser, and in the rubber and paper processing industries. It is actually a major component in kerosene and some jet fuels, which is the reason why it is important. I will show you the 2 isomers of the dodecaine that I chose. By the way, for your information, isomers are molecules or polyatomic ions with identical molecular formula. That is, same numbers of atoms of each element, but distinct arrangement of atoms in space. This isomer of the dodecaine is what we call 5,6-dimethyldecaine. Why? We have 10 carbons or a dodecaine as a parent chain. But then in number 5 and 6 carbon, there is also 1 carbon in each. So we have a total of 12 carbons. And aside from showing you the skeletal structure of it, I will also show you the structural formula of it. If you will count it and post the video, you can still have C12H26, even though it is a little bit different from what we've done a while ago in terms of its arrangement. Next isomer is what we call 3-ethyl-2,4-dimethyloctane. Since the parent chain is 8, we will call it as octane. And in number 3 carbon, we have 2 carbons attached on it, so we will call it as ethyl. And in number 2 and 4, there is 1 carbon atom attached on each, so we will call it as methyl. Here is the structural formula of it, and it is also have a total of 12 carbons and 26 hydrogen. In summary, the isomers that we chose are the 5,6-dimethyldecaine and the 3-ethyl-2,4-dimethyloctane. If you are a bit confused with this, you can actually chat me in my Facebook account, Christine Bizarre, or comment below and I'll help you, even though I'm still not expertise with this, but practice makes perfect, right? This is the end of our video. I hope you liked it, enjoyed, and learned a lot. Thanks! Bye-bye!